I'm extracting patches from a grayscale image, which is a fancy way of saying I'm taking smaller square chunks out of a larger picture. This is useful for image processing and machine learning. I have a 100 by 100 pixel grayscale image and I want to cut it up into smaller 10 by 10 pixel squares. The stride of 5 means I'll move 5 pixels over before I take the next 10 by 10 square. Think of it like sliding a window across the image. I'm going to calculate how many of these 10 by 10 squares I can extract. To find the number of horizontal patches, I subtract the patch width, 10, from the total image width, 100. Then divide by the stride, 5, and finally add 1. The represents integer division, meaning I only keep the whole number part of the result. I add 1 to account for the first patch. This gives me 19 horizontal patches. I repeat the same calculation for vertical patches. This gives me 19 vertical patches. To get the total number of patches, I multiply the number of horizontal patches by the number of vertical patches. 19 times 19 equals 361 patches. I'm defining the size of each patch I'll extract from the image. Each patch will be a 10 pixel by 10 pixel square. Think of it like selecting a small square area from a larger picture. This tells me how many pixels the extraction window moves across and down the image between each patch. It's like taking steps of 5 pixels at a time. I'll move 5 pixels to the right, then 5 pixels down, and repeat this process to extract more patches. This creates some overlap between patches. Pretty cool, huh? This is the result of applying the specified patch size and stride to the image, which is the total number of 10 by 10 patches I'll get from the 100 by 100 image. I'll calculate this number using the image size, patch size and the stride. Using the formula, the number of extracted patches is 19 horizontal patches multiplied by 19 vertical patches, both calculated as 100 to 10, 5 plus 1, which equals 361 total patches. I'm working with a 100 by 100 grayscale image. I want to extract all possible 10 by 10 pixel patches using scikit-learn's function. I'll use a stride of 5 pixels. That means the sliding window moves 5 pixels at a time. The question is, which statements about the resulting patches are true? I'm presented with multiple choice questions to check understanding of how the function works, specifically focusing on patch size, stride, and total number of patches. This is the overall topic. I'm focused on understanding how to extract image patches and interpret the results using the given parameters such as patch size and stride. This sets the context. I'm starting with a 100 by 100 pixel image. I'm aiming to extract smaller 10 by 10 pixel squares from this larger image. The challenge lies in calculating how many squares I can extract and understanding the function's behavior. I'm working with a 100 by 100 pixel grayscale image. Think of it as a 100 by 100 grid of pixels, each representing a shade of gray. I want to extract smaller square sections, or patches, each measuring 10 pixels by 10 pixels. Imagine cutting out tiny 10 by 10 squares from the larger image. The stride tells me how many pixels I move the 10 by 10 window each time I extract a patch. I'm moving it 5 pixels to the right and 5 pixels down each time. It's like taking a step of 5 pixels instead of 1. To find the total number of patches, I first calculate how many patches fit horizontally. 100 pixels to 10 pixels. Divided by 5 pixels, plus 1, because we include the starting point. That gives me 19 horizontal patches. I repeat this for vertical patches, yielding the same result of 19. Therefore, 19 times 19 equals 361 total patches. Each patch I extract will have dimensions 10 pixels by 10 pixels, as specified. That's guaranteed. If I increase the stride, say to 10 pixels, my 10 by 10 window will jump further each time and I'll get fewer patches, since I'm skipping over some areas. If I reduce the patch size, say to 5 by 5, I'll be able to fit many more patches into the 100 by 100 image, so naturally I get more. This answer, 441 patches, is incorrect. My calculations show there are only 361. I'm extracting smaller squares, patches, from a bigger grayscale image. Think of it like cutting up a picture into smaller pieces. We're tackling a problem involving image processing using a function called _extract_patches_2d from Sklearn. We'll extract 10 by 10 pixel patches from a 100 by 100 image, moving 5 pixels at a time. The goal is to determine what's true about the resulting patches. I have a square image, 100 pixels wide and 100 pixels tall. It's grayscale, meaning it only has shades of gray, no color. I'm using a tool to pull out smaller 10 by 10 pixel squares, patches, from this big image. I need to decide which of the statements about the patches are correct. It's a multiple choice question about the results of the patch extraction. Statement A claims we'll get 441 patches. I'll have to calculate whether this is correct. Statement B says each little patch is 10 pixels wide by 10 pixels high. That's a direct result of how I set up the patch extraction. Statement C says that if I move the extraction window more with each step, larger stride, I'll end up with fewer patches. I will determine if this is logical. Statement D says smaller patches would give me more total patches. Makes intuitive sense since more small patches would fit into the same image. This section describes the method for extracting the patches from the image, detailing the patch size and stride. Each patch is 10 pixels by 10 pixels, and the sliding window moves 5 pixels at a time both horizontally and vertically. This means that the patches overlap. I'm explaining how from Sklearn works. It's a function that lets you pull out little square chunks, patches, from a bigger image. Think of it like sliding a window across the image and grabbing a snapshot each time. We have a grayscale image, which is like a black and white photo. That's 100 pixels wide and 100 pixels tall. Our task is to extract all possible 10 by 10 pixel patches from this image. We'll cover how the method of extraction impacts the number and arrangement of these patches. The image's size is 100 pixels by 100 pixels. Each patch we extract will be a 10 by 10 square. I'll explain how the stride affects how many patches are pulled out. To find the number of horizontal patches, I subtract the patch width, 10, from the image width, 100. Then do integer division by the stride, 5, and finally add 1. It's like asking, how many times can I fit a 10 pixel wide patch into a 100 pixel wide image if I move it 5 pixels at a time? The answer is 95 plus 1 equals 19. The same logic applies to vertical patches. I present some multiple choice statements related to our patch extraction to test my understanding and yours. This is incorrect. I'll show you how to calculate the correct number of patches. This is correct. The function directly specifies the shape of each patch. This is correct. A larger stride means you skip more pixels between patches, so you get fewer of them. This is also correct. Smaller patches obviously mean more will fit into the image.